Let's do our next script, 2A. Just start from here. Right. So here we want to now do some trend line analysis. So let's say, what is the trend of some climate parameter? This is a useful kind of thing to have, and we want to generate a chart having a trend line. When you are working with the climate data, the trend period matters. So you might want to do a monthly trend of temperature, might be an annual trend, might be a seasonal trend, and so on. Your original data that you want to use will come at a different time period. So let's say we want to use this chirps data for rainfall. It's really nice precipitation time series data in long time series that is available. This data comes in as a pentad time series. So it's available from 1980 to current, really high quality data set, but you have one image for every 5 days, right? So if you plot a time series of this, you'll get a time series of rainfall every 5 days, which is probably not what you want, right? When you want a time series trend of rainfall, you don't talk about trend every 5 days. You might want a monthly trend or a seasonal trend or an annual trend of rainfall. So you have to aggregate this data to be monthly or yearly data. This is kind of common pattern across a lot of climate data. Let's say you want to work with ERA data. ERA 5 is very useful climate data. You have ERA 5 land. This is very widely used. This is an hourly data. You have one image for every hour. Now, if you want to do some analysis, you probably don't want to know the temperature every hour, right? You want to know maybe daily average or monthly average and so on, right? So if you want to use this, you have to aggregate this data to whatever time period you want. So one of the most important skills that you need to know is how to change the temporal resolution of your data. And this is called aggregation, right? So we'll now learn how to aggregate data. So we'll do annual aggregation, and I'll show you if you want to do seasonal aggregation and so on. So we'll want to generate annual precipitation. So let me just show you. So if I just want to print the original data, let me print the first 10 images. So the limit function will just print the first 10. Each image here represents the precipitation in a 5-day interval. So the first image is 1st Jan 1981. Second image, 6th Jan 1981. So this image says this is what the rainfall happened between 1st and 6th Jan, this one 6 to 10 Jan, and so on. Right. So now what you want to do is you want to say, I want to take, if I want to create annual rainfall for 1981, I would say filter this data to all 1981 images, sum them up, sum all the pixel values, and that's my annual rainfall. And I want to do this for every year of this. So the way you do this is, first you generate a list of whatever time period that you want. So I've generated a list here of years using the list sequence function. So you can see my year list has 40 items, 1981 to 2020. Yeah. So I have some list which I can map some function over, and that's the first step. If you want to have a monthly, you generate one more list from 1 to 12, and you can say for each year I want monthly. If you want, fortnightly data, generate a list of every 15-day dates, and you can map a function over it. Right. So first step is whatever time period you want, you generate a list. Second, you write a function to process one item. So we'll say, given 1 year, how do we create an image for that year? So we'll write a function. We'll just say create annual image. This function will take a year as the input and return annual precipitation. Right? This is what we want to do. So if I say, give me the annual image for 1981, this function should do this. Once we have this function, we'll be able to map this over this list, and it'll happen for all 40 years in parallel. Right? So this is something that we need to write here. Now, most of you will be able to write this function that given 1 year, how do we do this? Well, we say, I want to create a start date. So we want to filter the collection for the start and end date. So we'll say, what is my start date? You can use this date from YMD function and say, whatever year we gave, 1st Jan of that year is the start date. Okay. What is the end date? Well, it's the start date, advance 1 year. Okay. Whatever start date, advance it by 1 year. That's my end date. Now I can apply a filter. We'll just say, take my chirps collection, which is every 5-day image, apply a filter date, start date, and end date. So in this function, whatever year we give, we'll get all images for that year in this filtered variable. What is the annual precipitation? We'll say filtered dot sum of all the pixel values for that year. And we just return this. So we'll just return this total. Yeah. Let's see if this works. So we'll just say my yearly images will be years dot map. So this map, we need a function. So we can just map this function. And let's print. So I had a list of 40 years, and what you get? You get list of 40 images. Okay. We just aggregated our penta data to yearly. And each of this image was created by a different computer, right? In parallel. That's why you need to do map. Don't do iterate or don't do for loops. Right? You always write a function for map. One problem with this though is we have no properties. If you try to chart this, right, it'll not work because we at least need the timestamp. So we need to set the timestamp. So before returning this image, we'll say set some properties. So we have to create the system colon time start. At least all your images need at least this one property. What's our time start? Well, it's a start date, right? This is our start date, whatever year you had. This is a date object. We cannot store a date object in this property because this property has to be milliseconds since 1970. That's the parameter that converts a date into a number that Earth Engine uses. It's also called a Unix timestamp. So there's a function called .millis, which you can run on a date object, which will give you the number of milliseconds since 1970. Right? This is kind of the Unix timestamp standard. If you want to convert a date into a number, this is what you say. Whatever date, you count the number of milliseconds since midnight of 1970, and the number it will give you is the date. So we'll just set that. So now when I run this, you will see that I have a property for each of those 40 images. And now all my filters, timestamps, everything will work correctly. We can also create some other values. If you want to do a time end, might be helpful in some analysis. It's not required, but you might want to store end date. You also may want to store year just for you to identify or filter easily. So this image belongs to that particular year. So now you can see I have multiple properties. This is 1983, this one's 1984, and so on. We have now our yearly images. This one is still a list. And if you want to plot anything, there is no UI.chart.list, right? So you need to turn this into a collection. So we'll say I want a yearly image collection. We'll just say we have this function e.image collection from images, and we'll give a list of images, which will turn this into an image collection. So now we have an image collection of 40 images. Each image is the annual rainfall for that. Get used to writing code like this. This is a very important thing that you'll have to pre-process the data into different time periods that you want. If you want monthly composites from your mindset data, this is how you do it. If you want seasonal data for your time series analysis, this is how you do it. So now we have a yearly collection. Let's create a chart. So I'm going to create chart ui.chart.image.series, the same thing, autocomplete, and we'll just plug in our values. Region, we have a geometry. So this is the point geometry. Reducer doesn't matter since we have a point, but it's good to use mean. Scale is the scale of this data set, which is 5566 meters. And I can print the chart. And now we have the chart of annual precipitation at this point location over last 40 years. Somebody is asking, what is this year 11 doing? So let's look at this function. So this is a function that will create a date from 3 parameters: year, month, and day. So the start of a year is whatever year is there, 1st January. That's what one is doing. And then we advance it by 1 year. Many of you might want to do a seasonal time series. So let's say for this part of the world, the monsoon season starts on 1st June and goes on for 4 months. So if you want to now know what is the monsoon season trend of rainfall, we just did that, right? So this is, we'll say, give me all the images from June, advance by 4 years, June to September. That is the rainy season. And we now sum up only the rainfall that happened in the rainy season. And this is the trend of rainfall in the rainy season. This is also important for agriculture because a lot of the agriculture depends on a seasonal rain. So if you want to know how trend in rainfall might be affecting agriculture, you might want to do a seasonal rainfall, not just annual rainfall. Okay, so by using this kind of date functions, you can do this kind of processing much easily. So make sure don't hardcode your dates, just use the date functions in advance to create your temporal period. We have a chart. We want to plot the trend line. But before that, let's just make the chart a little bit better. I'm going to use the set options function here. We have the title, line width, and so on. Okay. Now we want to do a trend line. Can we plot a trend line showing is a trend increasing, decreasing, whatever? So let's learn about trend line. So this is a Google Chart Tools documentation on trend lines. Google Chart Tool supports 2 kinds of trend lines. One is a linear trend line. Whatever data you have, it'll fit, do a linear regression and fit a linear regression line to the data. And you will see that line automatically generated and added to your plot. You can also have exponential trend line. So if your data has an exponential pattern and you want to fit an exponential line, you can have an exponential pattern. You can also have a polynomial trend line. Yeah. So here we are aggregated data to yearly and the trend is linear. If you have more seasonal pattern, you might want to use a different kind of trend line. But now we have aggregated to a year, so we have a linear trend line. And this is done just using this parameter called trend line. And we'll have to specify what trend line for what series. You may have multiple bands, right? So which band you want to plot trend line to? And we'll just say trend line for 0. Whatever series 0 is there, generate a trend line for that. And we can give some parameter. We'll just say type is linear. So we have linear trend line for this. Trend lines. Okay, so you have a trend line. So this trend line is now generated automatically. If I hover over it, you'll see the equation. This is a linear regression equation. Y equal to mx plus c. And it just fit the trend line and give you that output. And this is a kind of very useful way to say you can dynamically plot this trend line on your data to show the trend on this. If I change the location, my trend line will change because it just fit to the values that are there. Within the trend line, I can also give options. I can give all my line width option. I'll say line width 1, point size 0. I don't want point, I just want line. Okay. So if I do this, I'll just get a single line for this. You can see, and now I got a line. You can also get a color. So whatever options you can give within for each chart, you can just give within trend lines that will control how your trend line looks. So let me show you some other parameters. Let me pop this out. This is what the chart looks like. We have this legend that is appearing outside the chart. We can actually control where the legend appears. So I'm going to show you this new parameter, which not learned so far. We can just say legend, and we have this position parameter. We can specify where the legend appears inside. So if you say legend position is in, You can see it's now inside of the chart. You can specify legend position top, bottom, right, left, in, out, whatever. Right? So there are different places. So we can put the legend inside of this. You can also put top or bottom and the legend will shift around that. Other thing that I want to show you is here chart tools automatically determine what is the good tick location. So it's now giving you a tick at every 200 millimeter interval. Maybe we want to change it. So if you want to have a customized ticks, you can say, I want my ticks to be customized. So let me just say for my V-axis, I want my ticks to be appearing at certain locations. So let's say I wanted 0, 500, and 1000. So you can see my ticks are only at those chosen locations. And so I can specify at what kind of exactly my ticks appear at which locations. So again, this is how you can customize this.